Um, we're going to today we are going to go over section 10.5, modeling projectile motion with parametric equations. So we're going to write parametric equations for objects that move uh, parabolically, like a parabola, an upside down parabola, and we call that projectile motion. Okay. So what you need is, I'll write it down, you need to know the initial velocity. It can be called v naught or just v for the initial velocity of your parameter. And then theta, an angle, the angle thrown, the angle at which the projectile uh, is thrown. So theta is the angle with the horizontal. So the angle formed with the horizontal. Okay. Um, so then you're going to use the following formula. And you might recognize this formula as in x equals the initial velocity cosine of the angle, and y is, very good, the initial velocity sine of the given angle. We did this, we had something similar when we looked at vectors, okay? Very similar. And multiples of t, except for one thing. We have to account something that's given, which is the constant g, and that is the acceleration due to gravity. So we call that g, and g is always, so it's a constant, and it's always 9.8 meters per second squared. That's acceleration, or 32.17 feet per second squared, okay, if you're in feet. So this will always be a constant. That's always going to be the case. All right, so back to our formula for a parametric equation that models projectile motion. We have x equals v cosine theta times t. Okay, that's our formula. And then y equals v naught, or initial velocity, sine of the given angle times t. But we have to add, and that's what makes us a parabola, the constant of gravity squared over 2. Sorry, the constant of gravity times t squared over 2. So again, g is 9.8. You can make that a negative 9.8 and a negative 32.17. So if the question that you're given is in feet, then you're going to use a negative 32.17. If it's in meters, you're going to use negative 9.2 for your constant. All right. So we're going to box that. Okay, so that will give you the location of the parameter, the x coordinate, the x comma y coordinate, where x is v cosine theta times t and y is v sine theta times t uh, plus g t squared over 2, where g is always going to be a negative. If you want to make that a minus from the get-go, that's fine. I'm okay with you changing this to oops, just a minus. So if you want to make that a minus, that we don't forget. Some textbooks have it like a plus, and then they remind you that G is negative, and some textbooks have it as a minus, and they tell you that G is positive. So it really depends on, um, the physics class you're taking or the textbook that you're using. All right, so we're going to use that for the next problem. So right now, I hope you got the formula down. Okay. And then we're going to use that for the next problem. Okay, so example 1 for today. Example 1. Baby Taralis kicks a ball across the yard at an angle of 60 degrees with an initial speed of 46 feet per second. Okay, let's write a set of parametric equations for the motion of the ball. And then we're going to determine how long the ball was in the air and how far the ball traveled. Then when the ball reached maximum height and what that height was for D. Okay, so, well, we're going to just use our formulas. So we have for A, x equals v cosine theta times t, y equals v sine theta times t minus g, which in this case we're in feet. So g is 32.17 feet per second squared. And times t squared over 2. Okay, so now we just have to plug in and that's it. So we have x equals v, which is 46, cosine of 60 degrees times t. So think back to your unit circle. The cosine of 60 is 1/2. So we have x equals 23t. And that's a parametric equation for x. And then for y, same thing. Y equals 46 sine of 60 degrees t. Y equals 46. The sine of 60 degrees is root 3 over 2. Y equals 23 root 3. Oops, I wrote a 33. Over 2. No, just kidding. Just 23 root 3 t. And then let's bring down the minus 32.17 t squared over 2. Okay. All right. Next, let's determine how long oh no, what's this problem? Let's determine how long the ball was in the air. All right. So in the air, we're looking at our y equation for part B. And we're going to set that equal to 0. So we have 23 root 3 t minus 32.17 t squared over 2. We're going to let that equal 0. Okay. A couple of ways you can do this. You can graph this equation and see when the graph equals 0. So I'm going to try doing that with either my graphing calculator or with Desmos. And you know what? I'm going to use my graphing calculator because I want you to learn how to use your graphing calculator. So I'll be back. I'm going to go get my calculator.